Hello everybody. In this video, we are going to go over how to conduct a t-test using SPSS. As you guys remember from class, t-test allows researchers to identify significant differences between two groups. So if you find yourself in a situation where you're comparing two groups across a numeric variable such as age, height, weight, income, IQ, whatever it might be, then you're going to be using a t-test. In particular, you're going to be using the t-test called independent samples t-test. In our example, we're going to be using the BRAINS dataset. This BRAINS dataset was collected by Willerman and colleagues in 1991. They wanted to see if there were significant differences between males and females in IQ. To do this, we will use a independent samples t-test. But before we even go to open SPSS and we start clicking away, it's really important that you guys follow the steps. And the first step is to establish your hypotheses. As noted in class, there are two hypotheses, the null hypothesis and the alternative hypothesis. The null hypothesis will always say that there is no difference between the groups. That translates to our case as the following. There is no difference in IQ between males and females. The alternative hypotheses will always say that there is a difference between the groups. In our case, that translates to there is a difference in IQ between males and females. These are two opposing statements about the world, and one of them has to be true. In statistics, we always test the null hypothesis, right? And if we able to reject the idea of the null hypothesis, then we come to the conclusion that the alternative hypothesis is true. We already went through the procedure to do that, which is the p-value. All right, so now that you have your null hypothesis and the alternative hypothesis, now you can run the t-test, and this is the instructions on how to do that. So let's just go over and do that. So before you click on Analyze and Independent Sample t-test, it's really important to understand how the groups are coded. In our case, groups are the gender. One group is male, one group is female. So we need to know how they are coded before we can start clicking away. So as always, we're going to click on Values, and you're going to see that 0 equals male and 1 equals female. This is going to come in handy in the future. So now we're going to go to Analyze, Compare Means, and you're going to click on Independent Samples t-test. The test variable is the variable that you're comparing. In this case, is the full scale IQ score. The grouping variable is the groups, and that is gender. SPSS requires that you tell it how the groups are coded. So you're going to click on Define Groups, and one group, as we remember, is 0, and the other group is 1, and you're going to click Continue, and then you're going to click OK, and there you're going to have your results. So the first table tells you the descriptive statistics. For male, it tells you that there are 20 males, the average IQ is 115, standard deviation is 24. For females, there are 20 females with an average IQ of 111. So it seems that men have an IQ 3.1 points higher than women on average. However, this difference doesn't mean that it is statistically significant. This might not be a real substantive difference. That is why we have to look at the actual t-test. So remember that the independent sample t-test gives you a lot of different information. And for the purposes of this class, we're not going to focus on the Levine's test for equality of variance. This is something completely different, right? So we're only going to look after this t all the way to the right. We are going to assume that the variances between the groups are equal. So you're only going to be looking across this row here. The t-value is simply a representation of the difference between the values. So the greater the t-value, the greater the difference. As you guys So here, the mean difference is just the differences between the means. In this case, the difference between the IQ between males and females is 3.1. Now, the key aspect of this is the p-value, which is given to you by this significance two-tailed test. And the p-value here is 0.68, which translates roughly to it tells you that the difference that you observe, this 3.1 point difference, there's a 68% chance that this difference that you observe is due to random chance. Because this probability is above our threshold of 0.05, we're going to have to accept the null hypotheses as being true. So, if the p-value is greater than 0.05, we have to accept the null hypotheses, that there is no significant difference in IQ between males and females. In other words, and by the way, in your reports and your homeworks, make sure that when I ask you to report the results, don't give me this table. I don't need this table. I need you to actually report the results. And the reporting of the results will go something like this. You will say something to the effect, while men have an IQ 3.1 points higher than that of women, based on the t-test, that difference is not statistically significant. So that sentence has to be there, but you also have to give me the t-value, which in this case is 0.4, and whether or not the p-value that you observe is greater or less than 0.05, our threshold. In this case, it is greater than 0.05, so you would say p greater than 0.05.